which is a good thing. Okay. So today we're going to talk about chapter 2, the first part. We're going to do chapter 2 this week. That means that we're going to have multiple lectures over this week. So we're going to get kind of the basics today, but the pretty important basics. So I can use it as a pad to avoid the allergic reaction of the driver. It can't be easy. That's going to cut. Okay. Okay. All that. Okay, so chapter 2 talks about, the first part of chapter 2 talks about how we're going to develop our programs. Okay. And it comes down to this, or it starts with this program development cycle, or life cycle, it's sometimes called. Okay. There are many such models out there. This one's called the waterfall model, for reasons that you'll see in a minute. So this is the general idea. I think there's a problem in beginning programming classes and kind of all college classes you take. I can't give you projects big enough to be real life, there's not time. So the projects we're going to be doing are simple, and you probably don't need all this apparatus. Okay. But we're not just learning the programming, we're learning the apparatus. Okay, so I'll ask you to do things that may seem like overkill for that reason. So our first step here is going to be to design the program. Okay. You can't write any code till you know what the code is supposed to do. So once you've done that, you go to where you actually write the code. And this is not everything I talk about is in the book, but this is all in the book. Okay. You then go into the correction or the correct syntax errors. Talk about errors here in a second. You then go in and to test the program. Then you go into the correction of logic errors. Okay. At that point, you go back and start over again. So we have different kinds of errors mentioned here. And in programming, there are 3 kinds of errors that you can run into. The first is a syntax error. A syntax error means that you violated the grammar rules of the language. Just like English has a grammar, every other language has a grammar. If you don't get the verb in the right place or the wrong verb form, you've committed a syntax error. Okay? So if, for example, you use the print function, which we've used, with one open parentheses, but you don't ever close it, that's a syntax error. The good news about syntax errors is that no program will run with syntax error. It will tell you right away, you got an error. Okay? So those have to be corrected for the program to run. The second type of error is called a runtime error. And this stuff is not in the book, by the way. A runtime error means that the syntax of your program is correct, but that something happens during the execution of the program that causes the computer to blow up. Not literally, of course, the program stuff. Okay. And these are usually things like a divide by 0 error. There are other things that can go wrong, but if you have a program that asks a user for 2 numbers and divides the first by the second, that'll work every time until you enter 0 at the second time. Okay. So it's a testing that checks for those runtime errors. I think the most damaging errors are the logic errors. A logic error means that you do not know what you're doing. Okay? If I tell you to write a program to determine the square root of a number, and in your mind, the square root is to take a number and divide it by 2. That's what you believe. So your program is going to take the user input, divide by 2, spit it out. You're going to test it. If there are no syntax errors, it's going to first check mark, fine. Runtime errors, yeah, you can put whatever you want, it's going to work. That's good. You think it works, but it doesn't work, right? So on your programs, if you want to make sure you don't have logic errors, you have to validate with an outside source. You have to go to a calculator and do a square root. Am I getting the right numbers over a range of numbers? In a real world situation where you've got someone you're programming for, you have to go to someone in the business and say, okay, give me some examples of what is supposed to work, what the answer is supposed to be. Okay. Other questions on any of this so far? Okay. Next, we're going to talk about the design process. Okay. The first thing you have to do is to understand the problem. Or understand the task you want to program. If you can't solve a problem, an example of a problem, on paper, you can't write a program to do it. If I tell you to give me the triumvirate of 2 numbers, okay, go, what are you going to do? Well, I just made it up. So there's no such thing. But you can't write that program unless you know what that means. Okay? If you want to know, is a number a perfect number? Well, you got to Google what's a perfect number. Okay, so you have to know what it is that you're trying to do. Okay, so that's the first step. The next step, then, you have to determine what steps you need to take. To accomplish that. Okay. And your programs have to be repeatable. They have to work for a wide range of inputs. Your program should work eventually. So thanks a lot, for everything that the user types in. If the user types in something wrong, you should tell them it's wrong. But it should always work. Okay, so you can't just test one thing and say that you're good. It's got to work for a lot of things. Okay, it's got to be repeatable. Okay. Again, early on, our programs are so simple, it's not really worth the effort to spend a whole lot of time on paper before you cut it. Okay? But I encourage you to do that anyway. Sometimes I'll demand that you do that on homework. Okay? Because you want to get in the process of having, first off, when you solve it by hand, you're sure that you know how it works. You verify your answer, and then when you run your program, you have at least one case where you know what the correct answer is. Okay? If you could do all the problems in your head that you're programming, why you're running the program? Right? There's no point. Okay? So it's going to be complicated. So you want to be able to have that in mind. Okay. So when we're looking at a task, the basic job, we talked about this before, the basic job of a program is to accept some input from somewhere. You'll need to know where. It's going to do some kind of processing with that data. Again, if your program pops up and says, how old are you? And you say 21, and the program says, you're 21. Why'd you write a program? Right? You didn't know. Okay. So we'll do some processing. And then typically, we're going to have some kind of an output. So when you're looking at a program, whether it's in homework or whatever, and again, sometimes I'll ask you to do this specifically. Think about it. What's the input? Where's it come from? What processing am I going to do? What formulas do I need? What kind of math am I going to do? And then finally, the output. Is it going to be something on the screen? Is it going to play a sound? Whatever. We don't play sounds. Probably won't play sounds. So, for example, if I have a program that says something like, determine the gross pay of a worker given the hourly pay rate. And sorry, my handwriting sucks. It sucks more in here. So if you don't understand what I've written, let me know. And the hours worked. Okay. So this could be a programming task. We'd probably actually be write a program to determine the gross pay of a worker given the hourly pay rate and the hours worked. Okay. So when we're parsing this, and to parse this means to go through and pick out parts, okay? For the input, we know we're going to have the hourly pay rate, and we know we're going to have the hours worked because it says given those, okay? Given doesn't mean that you know them already. It means you're either going to ask the user for them, which is what we're going to do at first. And we don't have this tool yet, we will later in the week. Or you're going to read it from a file, okay? So we can identify up here that the pay rate, I'll just make that a little shorter, the pay rate, sometimes this doesn't want to write. And hours worked. That's the input that we have, okay? As far as the output that I've just wiped out with my hand, it's going to be the gross pay. Okay? And the gross pay is going to be the pay rate multiplied by the hours worked. Okay? So the output over here is going to be the gross pay. And then again, the process we're going to have is going to be the pay rate times hours worked. Make this a box, it's like a function. And that's going to come in, that's going to come in, and that's going to go out. Okay. So that's how we're going to decipher this program. We would further have to figure out where's the input going to come from. You know, is someone going to type it in? Is it going to be in a file? We're going to read it from a web source or whatever. Once we have the pay rate and the hours worked, we don't need anything else. We can calculate, our program will calculate the gross pay and output that. Questions so far? So again, this is not in the book, but when I was a young mathematics student back in the golden age of Reagan, which you would like to do that. That's when it was. I came across a book called How to Solve It by George Polio. And it's a very influential short little book. I think I saw it in office. And what he tried to do was to generalize problem-solving techniques in mathematics, which is very helpful as a student. So this is what, and I put a link in Moodle to a summary that MIT has done of his book. Okay. So here's his general idea. Talks about kind of what we just did. We want to understand the problem. We want to look at it and make sure you know what's going on there. We want to devise a plan. We want to carry out the plan. And then you want to look back. And there's more detail on the Moodle site, on the link there. But the basic idea is when you see the problem, when you understand it, that's what we just did. Identify where the inputs are coming from. Identify what formulas you're going to need. Okay. Whenever I tutor people that are in algebra, I always ask them, well, what do you know? What do you need to know? And then what do you know about what you know? What formulas may apply? Same basic idea here. So you devise a plan, you carry out the plan, and then looking back, you're verifying that it works, you're verifying that it works efficiently, and there's not something that you're missing. So that's the general idea there. So all of programming, for the most part, is going to come down to some basic logical structures or tools that we can use. Okay? So almost all programs in all languages are a combination of these things. And the first is just sequential execution. This is not the book. Sequential execution is step one, ask the user for some information. Step two, perform this calculation. Step three, do something else. Step four, sequential, 1, 2, 3, 4. Okay. Early on, our programs are going to be all sequential. That's all we know how to do. Our Hello World program, sequential. One line, do it, do that. Okay. The other thing we have to do, you have to have some way to have selective execution. Selective execution is going to be, if the age is over 50, print out you're really old. The age is under 10, you're really old. Whatever you want. So you want to, it's with selective execution, not every single line executes, only ones that have certain conditions. Okay. The third tool we have, repetition. I'm not sure repetition has an A in it. It may not. You get the idea. This is where computers excel and where it's sometimes hard when you're thinking about how would I solve this problem on paper to translate that into how we can put it to a program. Okay. The computer can do millions of calculations in a blink of an eye. So don't ever hesitate just to have it take the long way around. It's easier to code, it's clearer to code. That's not a concern at all. Okay. So, and we have subvariants of all of this, but that's the basic idea. The program's either going to go line by line, it's going to only do some lines, or it's going to repeat a series of lines. Okay. And this gets us into some of the tools we can use to model what our programs are going to look like. Okay. And this first one is kind of old school. I think it's still useful. The book still does talk about it. When you get to algorithms, which is the fourth course of this programming sequence, everybody, all the CSC. We'll talk about flowcharts again. When I was a new programmer, they would give us little programming templates that were plastic that you could draw up because they were a big deal. So let's look at the normal, or the three things we just talked about. Okay. On a flowchart for sequential, the basic idea is called the process box. Okay, this could be something like x equal 5 would be a process box. Okay. You're not getting input from anybody, it's just you're making that statement. Or it could be like x is equal to x times 100. So it's a process. So a sequential program, and programs usually start with a little oval called start. The line with the arrow is the flow of the data. Sequential would just be a series of boxes, eventually going to an end. Let's break it up. I wonder if it's okay, so this is sequential. We come in and start, we do what's in this box, what's in that box, what's in that box. Okay. To aid us in this, we have input-output boxes, which look like parallelograms. Okay, it's be something like ask user for name. Okay. You could also do it as print X. Okay. Now those are not in the flow. Those have to be connected variables. But that's what those boxes look like. The process boxes get input output boxes. Now let's look at our selective repeat, or not selective repeat, our selective execution. We'll start a new one here. Start box. We'll go into a process box that just says X. Well, no, let's just go do a parallel with that. Let's ask the user. It's not like to write. So enter a number. N. That should be a parallelogram. It's not clear. Okay. Now, we don't always want to execute. Let's say that we want to only do something if the number is even. Okay. So a decision in a flowchart is a diamond. Ask the question, is X even? All the decisions here are binary decisions, either yes or no. So you'll have a line out if it's yes, you'll have a line out if it's no. Okay, so over here you could have something like print out, even, whatever. If no, say it's one end. You're not going to do anything. So then this one, you have to connect all the dots here. Once it does that, it will go to N as well. So that's what our selective execution is. And it's this input output box that is selectively going to be executed. And then on the repetition, we have to combine some things together. So for the repetition, you're asking the question basically, are you done yet? Okay. So the repetition will be the form of, and we'll do a subprogram. So you come to some point, you have to ask the question, are you done? You'll have to quantify that. Okay. If you're not done, then you'll go through and do some processes, input, output, whatever you want to do. Okay. And then at some point, you're going to go back up to there. If the are you done is yes, then you can go to end. So here's repetition. Repetition could be a counting loop where you're going to have a counting variable that's equal to 1, equal to 2, as long as it's less than 10, you're going to equal. Or it could be you ask the user for an input, and if they give some particular value, you know that you're done. So this is going to execute in a sequential fashion, and it's going to keep doing that over and over again until this done comes back as being the yes, you are done. Okay. So that's the basic flow of flowcharts. Any questions on that so far? We'll take some time to work through some examples here in a minute. Okay. So the last bit we're going to talk about today is going to be some actual Python again. I was looking, when I was looking at the ASCII table in the back of the book, the homework, and the homework's due, I know it says it's due at 2 o'clock, that's my last class, but you should turn it before this class. If you didn't, it's not necessary. But normally it's due at the beginning of the class. Okay. In addition to the ASCII table that's in the back of the book, there's also a whole guide to using idle. So if you're having trouble with idle, in addition to lots of stuff online, there's a section of the book that talks about that. Okay. So again, we're going to use the function we talked about before, print. Okay. Functions in Python, we'll talk about functions later. They're similar to, but not exact to functions in mathematics. Same thing with variables, it's not really the same thing. So we use terms kind of loosely, but we'll talk about it as we go. But a programming function means that it's going to take some parameter, okay, and then do something with it. In the case of the print function, all lowercase, all the commands in Python are lowercase. What it's going to take is a string or a string literal. Okay, by the word string, what we mean is going to be a series of characters, and the characters can be numbers, letters, spaces. The book used Kate Austin as its example. Okay. And that's a string literal. There's no variable name. We haven't talked about variables yet. But we can have string variables later, but that's a string literal. Okay. Or they can be, you always turn your phones off before class. But I didn't do that. So in Python, unlike some other languages, you can have your string literals in either single or double quotes. You can't mix it. So if you start with double, end with double, start single. Part of the trick of programming efficiently is making sure that you don't have to think about more than you're thinking. So I would pick one. What's a good reason? Use doubles, use singles, stick with it. So you don't have to decide every time. Do I use singles? Pick one. I'm not going to enforce that. It's just a tip from program for a lot of use. Okay. So all this program does, if I would say print hello, okay, on your screen, it's going to put, well, it wouldn't be those things, it would say hello. I can't write that. Hello, although it would be exactly like you wrote it. Okay. That's all it does, prints it out. By default, we're going to talk more about this later this week. It will then bring it down to a new line. That's automatically how it works. And there's lots of other tips and tricks we can do with the print command. I can't imagine a program that we're going to write in here that does not have a print command. So let me okay, questions on any of that? This is a lot of preliminary stuff. Let's go ahead and go into idle. Again, you're not stuck using idle. If you want to use something else, you surely can. Okay, but when we pop up idle, did we determine there was a way to make this bigger? A little easier to read. Okay, so again, when we're at the 3 greater than signs, we're in the shell mode. So if you want to print stuff out here, you certainly can. You can just do a print in all lowercase, open the parentheses. Notice that idle helps us out here. These are things we're going to talk about later. We have options here for the set, for the end. Notice by default, the end is equal to \n, and this chapter really talks about that. The \n is a new line character, which means when we print, it's going to go to the new line. Okay, so I can just print here. Hello. Hit enter. Oh, see what I did? What did I do wrong? I mixed them up. I told you not to do that, and I did it. It didn't help that they're on the same key. Oh, I can't do that now. Oh, but I can do, nope, I can't do it. In fact, on my Mac, I can do an up arrow. There we go. Okay. Gives us a new one. We're going to do more with this later, but that's the basic idea. Again, did I just write a program? I did not write a program. I went into the shell and I edited, or I made the shell do something, like right now. I can't repeat that. It's not a program. Can't turn that in unless you do a screenshot. Okay. So again, in idle to write a program, I'm going to go to the file, new file. And I think it's sometimes helpful to make these kind of side by side, because what's going to happen, your program's going to run in the shell. Okay. So if I just want, again, we've seen this before, but if I want just to print hello, that's all my program does. Do a file, save. Who knows where it's going to let me save it at? Desktop for me, maybe. Again, you should get in the habit of bringing in a jump drive. You can get them for like next to nothing. You probably can literally get them for nothing. So once you've saved it, you can then run it. And notice that over here, it's going to tell us that I'm running the hello there.py. It's located on the desktop. So if you're ever looking for where your file's at, when you run it, it should tell you exactly where it's at. And then here's the output of that program. Okay. If I had 2 lines, you'll see that it does do the new line character for us. Okay. So So far, so good. Other questions on print? We don't do much with it yet. Again, we'll do more. Okay, so this is in our input process output. This deals with the output almost always. So the last thing we're going to talk about as far as new stuff today is going to be comments. So comments are lines you add to your program that don't do anything. They're completely ignored by the computer, by the interpreter. So why do we put them in there? We put them in there as a note to yourself later. It could be a note as you're developing the program. When you see me do programs in class, I will often like section off the tasks that I need to accomplish from my code with comments so I can go and fill them out. You can keep track of things. Okay. They're also for other programmers later on. That later on programmer could be you. I know as a young programmer, I would write a program like, oh, I'll remember how to do it. I'll remember what this does, so I wouldn't make any comments. 6 months later, you're back in the code, you've totally forgotten. What was I doing when I wrote this program? Okay. So notes are useful. So comments are pretty straightforward. All you have to do is put the octothorpe, shift 3, £, whatever you want to call it, and then put whatever you want. Okay. Notice it turns in red, at least on this computer. When you run it, it makes no change at all. Okay. If you ever have a line that's blowing up and you don't know why, you just want to make it go away temporarily, you can take this existing line of code, you can put an octothorpe in front of it, and you've now made it non-executable. I'll run it again, save it. See, that line just doesn't work at all. Okay. So that's often something that you'll want to do. Okay. As far as programs in here, anywhere you program, there's typically going to be a style guide of things that you have to do. So these are things that I want you to put on each one of your programs. It's going to start with the program name. Okay. Whatever it is, you're going to put that at the very first line of your code. It's going to be followed by the programmer, which is you. If it's a group, if it's either a group assignment or a lab assignment, you'll put the name of everybody that's working on it. Okay. You then want to put the date of last revision, typically. Sometimes if it's a program you know you're going to be working on a while, you may put, this may be a list of who's made changes and when. So that could be a little more involved. Sometimes you'll have notes here, and you don't always have this. At this point, always have a section, but there may not be anything in it. Okay. So this is going to be where you're going to put what formula you use, any of that stuff. And then for now, at least, I want us to identify in our programs what the input is, what the processing is, and what the output is going to be. Okay. So again, by putting these notes in, it makes it easier for me. If for whatever reason your code gets separated from you, then I can see what's going on. But also it just makes sense that if we get in the habit of it. Okay. Any questions on any of that? So I wanted to talk real quickly about the homework, give you the homework answers, and then we'll do some examples of what we talked about. So I think I'm just going to do them up in here, which I know makes no sense, but we'll just use this as a word process. So problem 3 in the homework said to take 11, take 65, take 100, and take 255, and turn them into binary. Okay. And we've gone through that process again where you create your table with the powers of 2. It didn't say make them 8-bit. I would anyway, but you don't have to. Okay. But so for the first one, the answer should be 0, 0, 0, 0, 1, 0, 1, 1. For the second one, our answer is going to be 0, 1, and then how's that? 1, 2, 3, 4, 5. 1, 2, 3. Is that the right number? 1, 2, 3. These always make my head go. 1, 2, 3. That's it. Then for 100, we have 0, 1, 1, 0, 0, 1, 0, 0. If you don't put the leading zeros at this point, not a big deal. We'll eventually want to do that. We talked about before, the 255 is going to be 8 points. It's the biggest number that you can do in 8 bits. Okay. So I am going to grade that, but that way you can check yourself on the correctness of your answers. I'm not going to be real hardcore about making sure that they're correct this time. So 1101 is 13 in decimal. 1000 is 8 in decimal. 101011 is 43 in decimal. That's problem number 4. Okay. And then for problem number 5, I just made up the name Bob because it's short, and I am by nature lazy. Most programmers are. So if you look up B in the ASCII table, it's 66. If you convert that into 8-bit binary, it's 0, 1, 1, 2, 3, 4, 1, 2, 3, 4, 1, 0. Okay, so that would be the first digit of that. The small o is equal to 111, which translates into 0, 1, 1, 0, 1, 1, 1, 1. And then a small b translates as a 98, which is equal to 0, 1, 1, 0, 0, 0, 1, 0. Okay. So then the total answer would be 0, 1, 0, 0, 0, 0, 1, 0, space 0, 1, 1, 0, 1, 1, space 0, 1, 1, 0, 0, 0. So that would be the correct answer. Or if your name were Bob, which I don't think anyone's in. Are there questions on that homework?
So do we need to put the binary code in there as well?
The binary for that last one, that's all I care about stuff.
Oh, okay. Yes.
If you get those right again, I'm not counting right or wrong on this one. If you turned it in, you're good. Okay. But note the correct answer, corrected in your notes, because you may see a problem like this on the first exam. Okay, so we've got about 10 minutes left. So what we're going to be doing for lab tomorrow is we're going to be working on some of these flow charts. The one thing I didn't mention that the book does talk about, we may see again later, is going to be pseudocode. Okay, so pseudocode is just really loosey-goosey code. We'll talk about that some maybe tomorrow. Okay. But let's go ahead and do an example, and you can do the examples either in Notability, because you can draw in Notability, you can do them in paper. Somebody had a question, I'm not sure if it's this class or not. They had done their binary homework this time on paper. That's okay, just take a picture of it, upload to JPG, that's fine. Make sure that it's clear, make sure you have good handwriting. We'll eventually get the programs. Okay, so right now, why don't you go ahead and do a, can we make something up? This is dangerous. Let's do a flow chart for, you're going to ask someone their age, and then we're going to use, if they're less than 18, we're going to call them young. If they're between, if they're over 18 but less than 50, we're going to call them, I don't know, normal. I don't know what to call it. And then if they're over 50, we're going to call them old. So you want your flow chart. Start with the start, end with an end, and then go. So you can have an input box, asking them what their name is. Then you can have a series of decisions you're going to make to see if that age that they're using is between certain things. So go ahead and work on that. If you have questions, let me know. It's not to turn in, it's just for you. That was me. There's software that you can do flowcharts with, which comes in handy sometimes because you may find halfway through that you've drawn it really awkwardly. And that's okay. Just connect crazy lines. Sure. Take a couple more minutes and then I'll show you my solution. You will find in most things in programming, there's more than one way to do it. Some may be more efficient than others. That's it.
Every time it has to be a yes or no question.
Yes, 100%. Yeah, you can't say, you can't have different, you have to have a different diamond for every question. So this one's going to take a minimum of 2 diamonds. You probably could do it with 3 as well if you wanted to. Let's take one more minute. And I'll show you what I've got and you can ask some questions based on that. There is one homework problem for Wednesday. It's not much. But we will be there. Let me show you what I've got. Okay, that's what I do. So I've got my start. I go into my input output boxes do not always look good, but that is a parallelogram for input output box, enter age. You can put something more specific if you want. In my first box, I'm going to ask, is the age less than 18? If so, I'm going to print young and then go to end. If not, I'm going to ask the question, is the age greater than 50? If it is, I'm going to print old and go to end. If not, if it's not less than 18 and it's not greater than 80, then it's somewhere between 18 and 50, right? In which case I'm going to print average and left off. Closing. It's important even at this early stage to realize age less than 18 would not include 18. Okay, so when you're doing series of comparisons, you have to make sure you don't leave any out. So there's two cases. It's greater than 18 or it's less than 18. Is that true? Is it true that every number is either greater than 18 or less than 18? No, why not? It could be equal to 18. Okay, so in fact, that's so common in computer science, it's called an off by one error. And we all the time you run into your loops, your everything being off by one. Okay. Any questions about this? Could yours be different? It could be different. Apparently, everybody in the world wants us to know that the FDA has approved the Pfizer vaccine, because that's the third notification I've gotten in the last minute. Okay. So, time's up. That's all I've got. If you have questions, let me know. If not, remember tomorrow is lab. Lab is on Zoom. So we'll meet on Zoom. It's the Zoom ID that's on. It's on the very top of the contact info. Okay. The address is on the wall. Yep.
You can also do that with like an if statement where you only have to ask one question. So you can ask like, what is your age? And if it's less than 18, then it's this. Between 18 and 50, it's this.
Yes. In code, yeah, but in a flow chart, that would be, you don't have an if, so we only have the single decision. But yeah, in code, we have a lot more options. That's for sure.